Okay, my name's Doug Gallagher, and I'm one of the instructors in senior design for the mechanical engineering. Senior design is the capstone project for our mechanical engineers. And in my section, we typically make things like cars and dune buggies and human-powered vehicles. I've had students make rockets. I'll show you some of those as well. And this is a field that, I get both men and women that do this. I have women that are team leads as well as men on a lot of these projects. I don't require that the students, when they come in, have to know how to run machine tools or weld or do composite layups, etc. We teach them that when they get here, and they learn as they go. First couple parts takes them a little while to learn how to do, but after that, it gets easier. And generally about the fourth or fifth part, they can do things. And so I'm going to show you a couple of things that students do and have made. And then we'll go out and look at some of the equipment, and then we'll come back and talk about some other things. And then if you have questions at any point during this, go ahead and ask. So that you can get an idea of what we're doing. So I open this up anytime that students have questions, just pipe up and ask. I don't have a problem with that. In fact, I would prefer that. So anyway, so what I'm going to do is we're going to take a look at I'm going to set up and we're going to take a quick look at some pictures.
It's up to you.
It doesn't matter.
Yes, please.
They mix this up and you can see the foam expanding. And then this will cure and it makes the wheel. So they've attached, the tread is here, the carbon fiber's here, and this is then the foam that goes in between that's a softer foam. So that's how they make those. What I'm going to show you now is, remember the rocket? Did you guys see the rocket that's separated? Did that come through or not?
No, it didn't. I'm sorry.
Oh, you should ask. This, right now you should be seeing a machine that's winding the fuselage for that rocket. And I'll go back and we'll show the rocket. Okay.
Awesome, thank you. Yeah, that's what we're seeing now. Sorry for the confusion.
Yeah, no problem. This is called an X winder. It's what they use to put in carbon fiber, and it takes it off. The carbon fiber comes off this roll. Down in here, where my cursor is a resin bath. It puts resin on the fiber, and then it's wound on a mandrel. So this is how we make the rocket. And this rocket was made in 2 pieces. And they go through and do this. It took about probably an hour or so to wind the fuselage, an hour or 2, and then they had to let it cure. Because it's a resin, it has to harden. So they use carbon fiber because it's stronger than things like fiberglass and a little bit lighter. And they were concerned about the weight. So I'll go back and we'll show you the rocket one again. This is the rocket that you saw being wound. There's two pieces of that fuselage here and here. It's about 12 feet long. And this was a test of the drogue chute that comes out the top. So that one was successful. And then there was the main chute that they had to do. That would be So you're seeing the rocket split in half?
Yep.
Yep. So that was the main chute. The other was the drogue chute. So what happens on these is you, on these pieces, on the rockets today, because they don't want them drifting too far, when the rocket gets to its apogee, which is its highest point, you set off a drogue chute, which just lets the rocket, it's a very small chute that doesn't let the rocket drift, so it just stops and it helps cause drag so it comes straight down. Then when it gets about 1,000 or 1,500 feet off the ground, the main chute comes out to slow it down so it doesn't crash into the ground. That rocket that you saw there went about just under 10,000 feet, so not quite 2 miles up. And they launched this down in Hertzville, down in Colorado, down just south of Fairplay. The other thing that we do is we build race cars, right? So you see the race car? This is what they built. This was just an acceleration test. Now, everything you see on that car, they have to make. The only thing they can buy the tires and the rims and the engine. They can buy some of the brake pedals and the brake cylinders, but pretty much everything else they have to make. They make the frame, they do all the body work, they make uprights, etc. And we'll show you those as we go outside. And we'll take a look at what's out there. These are finite element pieces. This happens to be the displacement of components for that rover. These are different things which you're looking at where this is stress, this is factor of safety, etc. So what I'd like to do at this point is kind of take you on a walk through the shop so that you can see what we do and how we do it here. So I'm going to switch over to my phone. Okay, this is the weld table. This is where the students learn how to weld and then weld up their components. So we have a couple of different welders here. Both of these two welders here are what are called TIG welders. And they use, TIG stands for tungsten inert gas. And what they have is they have a tip that is made out of tungsten. And let me find the torch head. So this is a torch head. And right there is a piece of tungsten that is about a 1/16 of an inch diameter that they sharpen. And then from that, they have a foot pedal that they press and allows current to come through, and it heats it up enough to melt the metal. And then they will go through and they'll take filler rod like this and add it into the weld pool to do their welding. Now, with this machine here, I can weld both aluminum and steels. And students do both of those types of welding. So they will set things up, clamp it down to the table here, and then they can weld up their frames or whatever else they need. So I'm going to start with the rover. This is another type of welder, by the way, that the students will use. This one is a MIG welder. And a MIG welder has wire that comes out here. And as the wire comes out, it melts into the weld pool. It's like a hot glue gun, except for metals. Now, both of these machines require gas to keep the weld area clean, and we use argon for that, just because it's easier, because that way we don't have to switch between steel and aluminum. Aluminum requires argon. Steel, I can weld with argon, but I could also weld it with something called C25. So this
is the rover as it currently sits in construction. They're changing the design of it this year. So they're going to put a swing on up here, because the rules of this competition is that this whole thing, when it's built, has to fit in a 5 by 5 by 5 foot box. So they have to fold it up so that it does that. So everything you see here, students have made. So they've made these pieces here, and then they had to weld them. If you look underneath here, there's a weld. They had to do the welding down here. All these parts are machined by the students on the CNC mills that we have in the shop. And so they go through and they have to make everything you see. They're trying a new steering system this year. So this is a particular type of steering system called Bélier that runs on a parallelogram. So there's 2 of these. There's another one here. And the way this is going to work is the person up here will pull on a rod going back and forth that will turn the wheels. These pieces here will go out to the wheels, and they go out to these uprights here. And what they do then is they turn the wheels from side to side. But they have to make the wheels. So down here, they have made the treads. They've got to clean them up yet. But these are the treads they made. They're out of a urethane. They poured into urethane, put a piece of breaker board on the back side. In fact, the mold for that is down here, parts of that. This is the mold that they will use. This piece is the mold they'll use to attach the tread to the hub. So if we come over here, there's your tread. Here is the carbon fiber that the students have to make. And we'll go over how they made this. They have to make it in 2 halves. So they lay in these, you can see that there's layers of carbon fiber. There's 1, 2, 3, 4, and there's another one underneath. There's at least 5 layers of carbon fiber here of different sizes. And then they put it on the rim. There's about 3 or 4 layers on the rim here. And then you make the 2 halves. They will put a shaft in between with its associated hardware, and then they'll glue all this together. And once it's all glued together, what you saw in that other video was where they were attaching the foam between the carbon fiber here and the tread. And they're working on making a fixture today to do that. But the hubs and stuff are these pieces here. And there's more parts to this, but this piece here sits on the inside. Well, actually, in this case, this comes through the hole here. So that comes through the hole, and then there's a piece that goes on the inside. And then this sits on the outside. They glue it on with the special epoxy. This is where the brake caliper mount, or the brake rotor mounts, and then they have to make things to hold it on so that it can actually stop the vehicle. And that's what you were seeing in the other thing, is all this together. So this is what students do, is they have to design all this, test the stresses on it, design the parts, then on using lathes and mills, they go through and make the parts. So where they do that is we have equipment like this. This is a 3-axis mill. It has a tool changer up in there that holds 10 tools. This tool here is a probe so that it can go in and find the parts. And so you don't have to use something like an edge finder, which is what this is. But this is a fully automatic 3-axis mill, which means it moves back and forth in X. this way and Y, and then the column moves up and down. So they learn how to program these and then run them. They learn how to set up their parts, run their parts. Then if they have to do secondary operations, they learn how to do that as well. Kind of give you an idea. So you can see the head moving up, and the table will come. Now, in this shop, we have 3 mills. Well, actually 4. We have 3 3-axis mills, and we have 1 2-axis mill that you move the quill, the spindle manually. So these are the type of machine tools that students learn how to use and program. And it does tool changes by itself. So you just program up the tools that you want to use. It will go through and run them and make the parts. That's what you saw in that one video of making the gear. We have another 3-axis mill here that the students use. Same type of thing. This one has some vices set up in it where the students go through and they can put their parts in. You can see the tools that they have. They've got counterbores and drills set up for drilling holes. This is our 2-axis mill. So this one moves, you can program it up to move in the X and Y. The Z then you have to run manually by hand. So you just move it up and down by hand. And then we have a small mini mill here that has to be repaired yet, but we're getting there. The other type of machine we have is a lathe. These are lathes. Lathes are meant for round parts that are bodies of revolution. So those are like the hub that I showed you where they're going to mount the brake rotor to. This is the type of machine that they're turned on. So you have a tool here that can then come in and move and do any contour you want. There's a tail stock at the end for putting center drills and drills in to drill holes in the pieces. We have a couple of lathes that are CNC. So here's a piece where he's getting ready to make a handle for an ice scraper that I have students make. The finished product looks like this when they're done. So this is the beginning of an ice scraper handle. There's will be a slot and a couple holes in here, and then a blade goes in. It's something I have my students do in manufacturing design process early on. Now, here are some pieces that they wound on that X winder that we saw in the other room that, we saw the video of. So it was wound on here. It's a little rough here. They had to cut some pieces off, but these were test pieces that they're going to test for strength then to see how strong they are. And they'll put them in a tensile test machine, actually our compression in this case. They'll just use the tensile test for compression to test both how much strength it can take going down this way, as well as the strength coming in this way. But these are the type of parts that students make. And they lose all the equipment in here. You have saws for cutting stock, for rough cutting stock. So right now there's a log of about 6.5, 7-inch Delrin in there that they took a chunk off of to make some caps for this. There's band saws. But these are student workspaces as we come through the shop. Now I'm going to go show you the FSAE car. So this is an FSAE car. This is the frame that the students had to weld up. And if you notice, there are pieces that they're putting together on the car like these uprights here. They had to make the spindles here the wheel goes on here. These are made out of aluminum that they've anodized to this goldish orange. But they have to make everything that you see here. The students had to weld all this up. They had to weld all the frame together. They can buy components like shock absorbers. We don't make them. Maybe we should. I have 2 students in FSAE here who don't think it's that funny. There's brake cylinders that they can buy and they put in. This whole assembly here has to be adjustable. That's why there's grooves down there so that they can move it back and forth, because this car has to be built so that it can handle from the 95 percentile man to the 5% female. So it has to have adjustment for the length for people's legs. They put the frame in and then they'll put the seats, the dashboard, everything else. The engine will go in here. The engine's over there. They have to come up with the drivetrain. So once again, you've got your spindle back here that rotates, the wheels will go on. This is what students do. They have to design this, do the stress analysis on it, then they have to go out and build it. So components like this, they had to machine. Some of this, the rods here, they made these adjustment rods. So one will have a left-hand thread and one will have a right-hand thread, so you can turn it and it either comes in or out as you do. And they have to make the bell crank, etc. Weight is important on this. The cars they've made in the past have weighed about 550 pounds. They're trying to get this one down to around 5. Hopefully they'll make it, because competitive cars are down in that area. So they've even gone as far as making things like gas tanks. They make their own gas tanks. They either weld them up out of aluminum or they'll make them out of fiberglass. Something else that they've been working on lately is cars like this are required to have a quick release on the steering wheel, so that if they get in an accident, you can pop the steering wheel off. But as you can see in here, there's what's called a spline. So they need to make a shaft for that spline. So this is what's going to be, the spline's going to be put on. To put that spline on, we're going to use a machine called a sinker EDM. And right now over here, we have one that's running to do that. So if you look down in there, you can see there's a little bit, you might be able to see there's some little blue sparks. And there is what looks like a serrated piece. This is machining the metal by vaporizing it. That's how this one works. It takes and it actually vaporizes the material. The electrode that it's burning with looks like this. So this was the roughing electrode. This is the dirt, the black color that you see on there is nothing more than the chips. They're very, very small chips. And I can actually just take a paper towel and wipe that off. As you can see, it's just kind of, it's the chips that burn. So they cut this out on another type of EDM. EDM cuts only metals, and it only cuts metals that are conductive, of course. So it's just sitting there, and what this is doing is it's moving back and forth this way into the electrode, and it's just cutting it away. If I go look, up here in the corner, what you see there is it gives me a measurement of the voltage and the current as it's cutting. It runs in a square wave as it pulses to vaporize the metal. And this is the voltage. It's running about 80 volts and maybe about 2 or 3 amps is all it's doing right now. But it will completely clear out that material and make those slots so that that piece then, so this piece then can slide on to a round shaft. I can make that. And to make the electrodes, so to make something like this, what I do is I have another machine here called a wire EDM. And the wired EDM uses exactly, the reason it's called a wire is it's a little hard to see here, but there is a piece of 10 thousandths diameter brass wire in there. And that acts as an electrode and creates the same type of spark that you see over there. And it has, because it's only 10 thousandths, it has a very small curve. So like here, you can see the shape of a wrench that was cut out. I drilled a hole and fed the wire through. And then it went through and I drilled holes here and here, so it cut out the interior. And then I fed it in here and then it cut out the wrench. There's only about 12 thousandths spacing between this piece and the edge. And so to make that electrode, I did exactly the same thing. I fed it in and then cut out the spline in the inside, and then I cut out the exterior. So these are the machines that the students learn how to program and use. Another thing they learn to do is, we talked about composites, right? Like those carbon fiber wheels for the Odyssey rover. They learn how to use a machine here. This is called a shop bot. This cuts wood or foam. And so they will put their piece on here on the table, screw it down with just wood screws, and then cut out what they need, and they can make molds. So I'm going to show you some of the molds and then how we do some of this. So I'm going to go next door because we have a composites lab next door. So I'm just going to walk through the shop a little bit. Does anybody have any questions?
I don't think so yet.
Okay. We're in another part, and these are molds that were made on the shop bot. This is for the side pod on the FSAE car from last year. And this was a mold that was made on that shop bot, and then they made it in stages and then glued it all together, and then they have to sand it down and fill it in. Then they can prep it, and then they can lay the carbon fiber on, and then breather cloth or release ply, breather cloth, and then vacuum bag it. And then they use things like these vacuum pumps here to suck it down. And so they've made a lot of molds doing this type of work. There's some molds down here for doing wheels. These were molds that were used for those pieces of carbon fiber that the carbon fiber wheels that you saw in the other shop. There's the mold that was cut. And it's got the relief down here for that square that's in there. So this is ready then for the carbon fiber layup. And there's one for the inside and one for the outside. I don't know which one's which right now, but this is what they use. And they make their own molds, they prep them, and then they go ahead and they do their carbon fiber layups. Now, the X winder itself is back here in the composites lab. This is the X winder. And so this is where up here is where that spool sits of fiber. Then it comes down here, runs through here. The resin bath is in here, so you just keep resin in there. It comes back out up here, and then there's a head that comes out and rolls it onto, as this rotates, there's a motor over here that controls the rotational speed, and that's synced to the speed that it pulls it off, et cetera, as it winds the piece. And they learn how to use this as well. There's a lot to learn in this class. You not only have to do design, but you have to do the building yourself, because I don't do the building for you. An example, by the way, of a previous gas tank that they welded for FSAE is here. So the students designed that and then had to weld it up out of aluminum. They wanted lightweight. Here's give you an example of the type of work that students do with carbon fiber, other pieces that they make. This is a seat that they made for the FSAE car. So there's slots up here for the seat belts. There's slots in the corners for seat belts, and then the ones that come up between your legs. But that's the type of things I expect students to be able to do. We'll go back because there's a few other things I want to show you. This is the hub that we have. We have a couple of garage doors here so that people can get their cars in and out. Things like the FSAE car have to be able to get out and be tested.
So that kind of gives you an idea for the composite work. I wanted to give you the steps that you have to go through to give you an idea of what's involved in actually making like just half of one of those wheels. So you should be able to see the mold for the wheel. This is a previous version that I have photos of. And
We can see it.
okay, does it change as I move?
Yep.
Okay, good. So we put a snorkel on there because sometimes the fuse coming off are not healthy for you. So they prep this. They have to lay in, they have to take their carbon fiber, they weigh their carbon fiber, and then they have to mix up the appropriate amount of resin for the weight of the carbon fiber. So that's what they're doing here. They weigh it. Once they weigh it, then they lay the carbon fiber down on a piece of film. They pour on the resin, then they lay another piece of film over it. So that's what it looks like. And they put templates around here for the different sizes. Remember, there are different size circles on that one when you looked on the inside. That's what you're seeing here. And then they will take a plastic squeegee and they'll move they'll move the resin around to make sure it's all wetted like this. So it's smooth on the inside so that it has resin throughout. It's impregnated is what they call it. They put that on. Then they cut their pieces out. So on that bottom layer, there are 7 pieces. Then they go through and they have to cut the sidewalls using the impregnated resin, clean off the swarf. Then here you can see the layers being put into the mold. So they start with the big ones and then they work their way in, and they put the side pieces on. Once all the carbon fiber is laid up, then you lay what's called a release ply. This doesn't stick to the epoxy resin they're using. It comes off, ideally. Once all that release ply is in, then you lay in what's called breather cloth. The breather cloth allows you to pull a vacuum on and get all the air out so that you compact the layers so that they're very tight together. Now this we do both on the FSAE car, we do this on the Rover. There's quite a few projects that we do layups like this. Once the breather cloth is put on, then you put on vacuum film. Then we pull the vacuum using that vacuum pump that you saw over in the other room, and then you let it cure. Pull the vacuum about 21, 22 inches of mercury. There's the part completed. Here's where they're assembling it with the hub. The 2 halves are going together. that was prepping the mold. Here's actually a small video of they're just, as they lay the first layer in, making sure it goes in the corner using brushes after they laid it in. So that's the techniques that are used. And then I've shown you this where they're now combining to make the complete wheel. So, any questions about what we do and how we do it? So students have done, I've had students make airplanes, remote controlled airplanes out of carbon fiber. I've had students make hovercrafts that they could ride. So it's a wide variety. I don't choose the projects for the students. They choose their own. If they can convince at least 3 or 4 of their friends to do that, and it's complicated enough to consume 9 months of their life, I let them do it. That's the way we do this. So, any questions?
I know that I am curious, what is one of the wildest projects you've let students or had a student work on?
We had a group of students once that wanted to make what's called a Tesla turbine. And a Tesla turbine it's a series of flat plates. And what they did is they built a rocket engine that ran off of hydrogen peroxide. It was running off of 75% hydrogen peroxide. Anything above 70% is considered rocket fuel by Department of Transportation. And to do that, the old V2 rockets that the Germans used were hydrogen peroxide rocket engines. So they made a rocket engine, and then they took the output from the rocket engine and put it into the Tesla turbine to get it to spin. The idea is they were trying to make an engine they could take to the Bonneville salt flats and compete for steam turbine cars. They didn't have enough people to actually build the car, but they did build the Tesla turbine and the rocket engine. The problem was trying to find a place to test it because the school wouldn't let me test it down here because of its volatility. The risk management told me no. But there happens to be a company called Frontier Astronautics that's just outside of Chugwater, Wyoming, where they bought an old missile silo and they test hydrogen peroxide rocket engines. So the students went up there one Sunday and tested their rocket engine. And that's probably one of the wildest that I've done over the years. I can probably, if I could remember the year that was about. Yeah, I'll share the video of that piece. Let me get back to Zoom here. This is up in the missile silo. Can you see that?
Yeah.
Okay. So right here is the Tesla turbine. On the other side of it is the rocket engine. This is a beer keg that they have filled with hydrogen peroxide. They use beer kegs because the insides are lined with stainless, and hydrogen peroxide at that level will eat anything except stainless steels, glasses, and some plastics. It will eat through steel. So they had to make this frame. This is inside the missile silo. There's a flame pit beneath this, but this is where they went and this is what they did. This is student, they made this, and you'll hear, because I think I've turned the sound on. They ran the hydrogen peroxide over silver screens because that automatically turns it into steam. It breaks it down, it's a catalyst, it turns it into steam. And it runs, the reaction chamber on this ran at about 750 degrees Fahrenheit. just speed it up a little. Whoops. I won't get too far. This was a team of 7 students. If you look over here, this is where the students look in. Now, what you will hear is the turbine eventually winding up. Okay, so eventually it wound up and then it wound down. What happened there is they had a control mechanism that was supposed to sense the RPM and shut it down at about 6,000 to 8,000 RPM. It failed, so it just kept getting more fuel. We estimate that it ran up to somewhere in the neighborhood of 20 to 30,000 RPM. And then what happened is the bearings were only rated for 10,000 RPM. So it welded the bearing to the shaft, and that's when it stopped. So yeah, we've had some wild projects. I've also had students that have made hovercrafts, like I said, and ones that they could ride on. They took it over to Sloan's Lake and drove it around. So, and the students have, I mean, I don't require that they build the engines. They can buy engines, but you know, pretty much like the hovercraft, they had to make the body and everything to hold it. So wild projects, you know, it's fun stuff. I have a lot of fun with the students that I have here. So.
I have one.
Okay.
So how does a program like this fit into a biomedical engineering program?
The techniques that we use in the shop are the same techniques you need when you need to design and build equipment for your biomedical. Things like the wire EDM and the EDM machines and the mills, I have used for doing, probably about 15, 20 years ago. I designed and built some stuff for Anschutz for testing bones. They needed a 3-point bender for testing bones. But you have to be able to design and make the equipment to test the strength of bones and stuff like that. So these type of equipment is the same type of thing that you would use, same time techniques. You know, there's not a lot of difference in that respect, because I've done a lot of work for some of the people at Anschutz over the years. Same kind of techniques are used. So.
Yeah, and then like Sean said, he built a bioprinter using those techniques and those machines. And even when doing prosthetics and whatever else projects.
I've had students design prosthetics.
Yeah.
I had students design one that actually, they had designed a prosthetic from the knee down. So if you had amputated just above the knee. So it had a knee and then a foot, and they had put in a pneumatic mechanism so that if you started to trip, it would catch you a little bit, like one really does. I also had some students that designed a robotic hand and arm. So it had fingers that moved, a wrist, an elbow, and a shoulder. So it would go, if you had lost your arm from the shoulder, you could actually sit there and it would move. It would rotate about the shoulder, the elbow, the wrist could rotate a little bit, and the fingers would move. So all this is applicable. And today with some of the 3D printers, like they have a 3D metal printer in the mechanical department that can produce aluminum parts, there's very little you can't really make with a little bit of ingenuity. Mechanical and the biomedical, they're kind of made to go together. There's a lot of overlap there for the components. The same techniques that they use to design and build those hubs out there for the car, are the same type of thing you'd have to do to build digits for a hand. Same kind of, tools and et cetera. They still have to be made one way or the other. You talk about the biomedical stuff. I retired from NIST up in Boulder, and we worked a lot with CU Boulder, and I can remember building a bioreactor for taking hydrogel, and what they were doing was testing some of the stem cells to see, they wanted to know how to rebuild cartilage. And so a guy designed the bioreactor, and then I redesigned it because what he had wasn't going to work. But the bioreactor basically took hydrogel in little, they must have been about 5 millimeter cubes of hydrogel. They would put a saline solution in there, and then we'd have 5 of these little cubes that would then sit there, and we'd have platens that would come down and push on them. And when you take the material for cartilage can actually form 19 different types of material depending on how it's stressed, everything from scar tissue to the cartilage that's in your shoulder or your knee. And the question was, could we take somebody's stem cells, put it in there, and regenerate cartilage where they'd completely worn it away? And what was the frequency that was needed and the amplitude to create that? So you want applications to biomedical? They're there. Same techniques.
So is this a class then that can be taken if you're not a mechanical major?
Yes.
Okay.
If you can tie it in to some kind of a mechanical project, certainly. I have electrical engineers, and I've had computer science that work on projects here that have a mechanical component. In fact, one of the guys that was out in the shop, he's an electrical engineer because he's doing all the electrical on the car. There's a Hyperloop car that we built for Elon Musk's competition that was held down in Hawthorne, California. And that was a combination of electrical, mechanical, and computer science, because it had to be controlled completely remotely. And the timing was pretty critical because they didn't get a run in the tube because they only had 4 teams that could run out of the tube out of the 20 that qualified. But they had to build that and then test it, and they had to run over Wi-Fi. And the timing was pretty critical. So there's computer science majors that were involved as well as the electrical. But I could certainly see if you're doing prosthetics or something, you'd team up with some mechanicals to come up with a project, and that certainly could be done here. I'm not opposed to doing those kind of projects at all. Probably going to need an electrical on your team as well for the motor controls and all that kind of fun stuff, but just something to think about. But this shop is set up for the engineering department. So, I mean, I just happen to run the mechanical senior design capstone, but that doesn't mean that if you have projects that are part of the engineering department, you can't come down and use the equipment. And I will train you how to use the equipment as well. Don't care. Done a lot of that. Okay.
Any more questions at all?
I just wanted to say thank you very much for your time. I found all of that fascinating. So thanks for coming, sharing about all of that, and letting us know about those resources and the cool projects you're working on.
Oh yeah, for me, it's fun. This is my retirement job. I've retired from NIST, and so I do this for fun. Okay. Nice meeting you.
Yes, thank you for doing this again, Douglas.